Good evening, geometry students. We are now starting a new unit called Special Right Triangles. This is one of my favorites, and it not only is the lead off into trigonometry, but also it leads off into this particular thing of trigonometry called the unit circle that is legit one of my favorite things. So I'm really excited to be teaching this, even if it is to a camera. I hope you enjoy it as much as I do. So basically, this unit starts where similar triangles and similar right triangles left off, in that every single triangle that has the same three angles but different sizes is still similar, aka proportional. Their sides are proportional. And so, what if we started with a triangle, that is, we started with a bunch of triangles that all started with the same sort of thing, a square. Except I'm going to take this square and cut it down the middle with my magic scissors. So let's see. With the square itself, the big question is, what would the angles have been? Obviously, a square has four right angles, so 90 degrees, 90, 90, 90. However, once we cut it down the middle with my magical geometry scissors, these two 90-degree angles are bisected. That means they're cut in half, and if they're bisected, that means they're no longer going to be 90, they're going to be what? Say it. Perfect, 45. So that means this is now 45, this is 45, and this is 90. This is our first special right triangle, and we call it a 45, 45, 90 triangle. So let's take a look at this and see if we can figure out exactly some more information about it.
So, if this is the 45, 45, 90 triangle that we've just created, let's say that we started with a square that had sides lengths of 1. So that means this would be 1 and this would be 1. And then the question is, how can we find out our missing side length? Well, obviously, let's use the Pythagorean theorem. So, let's see. A squared plus b squared equals c squared. And then, in this case, our 1's are our a and our b. So that'll become a 1 plus 1 equals c squared. 2 equals c squared. Take the square root of both sides, and, oops. And we've got the square root of 2 is our c. So there we go. We've got now a square root of 2, and that's going to be our c. Fantastic. 1, 1, rad 2. But who cares? What's the big deal? Well, let's come back to this, and let's assume that instead of the sides being 1, now let's assume they were 2. Well, let's do the same thing. A squared plus b squared equals c squared. So that means 2 squared plus 2 squared equals c squared. So 4 plus 4 equals c squared, or 8 equals c squared. This is why I was having us do simplifying radicals, because now we're going to get rad 8 equals c squared. And you may recall, I'm going to show a little more steps to do this than I normally would, but recall that 8 is 4 times 2. I meant rad 8 is c. And then square root of 4, square root of 2. So therefore we have 2 rad 2, which means that the hypotenuse there would be 2 rad 2. You know what? I'm going to collect these down here at the bottom, and I'm going to say our first one was 1, 1 rad 2. And now this one was 2, 2, 2 rad 2. Just looking to see if I can find a pattern. I'm going to erase this once more and go to the inevitable 3. What happens this time? So if I've got 3 and 3, a squared plus b squared equals c squared, what we're going to do is show every step so everybody gets it. So we've got 18 this time. So square root of 18 equals c. Well, that is, of course, 9 times 2. Split up the radical, and we've got 3 rad 2. Shabam. So 3, 3, 3 rad 2. Let's come back down to this. I'll just squeeze it in here. 3, 3, 3 rad 2. I wonder if there is a pattern here that we can use. Well, obviously, the two legs are always going to be the same thing. Those are great. And this looks like we just take that leg length of a 3 or a 1 or a 2 or whatever and just multiply it times rad 2. So it's going to become 1, 1, 1 rad 2, 2, 2, 2 rad 2, 3, 3, 3 rad 2. Or, in other words, what we would do then is let's generalize this and write A, and what would go there? A rad 2. Shabam.
Okay, now at this point, I would like you to keep this video going, but at the same time, open up a new tab and go to your Google Classroom to today, and you will see a slideshow that is called Number 1, Goku. Open that up, please. While you're doing that, I will explain why is it Goku. So at my previous schools, I named all my worksheets just because it was fun. And so every different unit had a different TV show, like The Simpsons or Dragon Ball Z or Sailor Moon or whatever. Always cartoons, always delightful. And so this unit I have decided is going to be Dragon Ball Z. Goku is the main character of that show. And in fact, there's 4 different series that he's the main character of. He's pretty big in Japan, and so he is the first character that we're going to be covering. And so after the title slide, you will see right afterwards there is a guided practice slide. Go to that second slide, please. Oh, we're still on. So let's look at these 1 through 4 together. Again, you don't need to look at me right now when I'm going through this with you. You can just listen as I look at the guided practice in your other tab. So here we go. Number 1, we've got a 45, 45, 90 triangle, and we have 8 and 8, and basically all we need to do is solve for that x. Well, using the same pattern that we just sussed out, that would be 8, 8, and 8 rad 2, and you're done. This is an amazing shortcut because it gets rid of all of that huge Pythagorean theorem stuff that we just had to do, and it just 8, 8, 8 rad 2, shabam, you're done. Number 2, therefore, 14, oh man, but they didn't give us the other 2 sides. Doesn't matter. Same sort of thing is true. The y side there is 14 because both of the legs have to be 14, and the hypotenuse is 14 rad 2. You're done. 14, 14, 14 rad 2. Now look at number 3 and 4. Those I've kind of flipped it on you, and this time I'm giving you the hypotenuse and you need to find the legs. However, it's not really a trick. So for number 3, we have x, x, and 10 rad 2. What do you suppose that your x leg would be? 10. That's it. 10, 10, 10 rad 2. And then finally, number 4, this time we have x and y, and then the leg is 12 rad 2. So what are x and y going to be? Well, they're both the same thing. X and y are both 12. 12, 12, 12 rad 2. So as you can see, there's no big surprises here. It's just x, x, x rad 2, a rad 2. It could literally be pi, pi, pi rad 2, a million, a million, a million rad 2 if I felt like it. So now I'm going to stop talking for a second. Open me up again. Hi, press pause, and I want you to try the independent practice. Here I've moved a whole bunch of things around, but there's just a couple problems there that I want you to try without my help. Thanks. Quick little break. First of all, this is Archie. Oh, and Rory. Rory, you're tomorrow. You're tomorrow. This isn't your cue. So this is Archie. He is my youngest son. He is 1 year and 2 months old, and he is a rescue mutt. And he's great. Rory, his big sister, loves him very much. His favorite things are snuggling and chewing and being really cute. Yeah. So he's Archie. Rory loves him dearly. Okay. You ready for more? I know I am. So now let's return to another classic shape. In fact, probably the first triangle you ever learned about back in kindergarten or before. And that is an equilateral triangle, aka equiangular, aka regular. All of these are true. So in this case, of course, we have 360 angles, 60-degree angles, because they all have to add up to 180 degrees. But again, I'm going to take my magic geometry scissors, and I'm going to cut. This time, however, I'm going to cut down the middle, like this, like a piece of pizza. And zoop. just like that. And so now let's take a look at what right triangle we have created. Well, this angle is of course still 60 degrees. This angle was 60 degrees, but when I cut through it, I ended up bisecting it, much like I did earlier with the red one. So now instead of 60, whoop, it is 30 degrees. So finally, looking at this one down here, when I cut it, to cut it like a pizza, what I actually ended up creating was an altitude. We've discussed this before. An altitude is a line that starts at the vertex and then goes to the opposite side at a what degree angle? 90. So what this ends up giving us is a 30, 60, 90 triangle. Let's explore.
And we're back. Okay, so let's assume that with this equilateral triangle, this giant one, I'm going to assume that all of the side lengths of that were 2. So 2, 2, 2. In that case, looking at this then, the side length of the hypotenuse is going to be 2. Then that leaves me to think, so what is the side length of this one going to be? Well, since I cut it through the middle, and with my little magic scissors, and it was like that, this whole bottom used to be 2, so now it will just be half of that, aka 1. So what we're missing is this side right here. Note, we're missing the leg. We're not missing the hypotenuse this side, we're missing the leg. So when I do the exact same thing I did earlier of a squared plus b squared equals c squared, so I'm going to write in 1 squared, but I'm going to leave b alone, and I'm going to plug in 2 for c. So 1 squared is 1. Please don't say 1 squared is 2. And then equals 2 squared. Archie, Roy. Really? Anyway, then subtract 1 over to that side, and we'll get b squared equals 3. Take a square root of both sides, and we have the square root of 3. Shabam, we're done. That's it. Square root of 3. So, like I did last time, I'm going to come down here and write 1 rad 3 and 2. But again, like I did last time, let's shake things up a bit and assume that my side lengths were different. So this time I'm going to assume that they were 4. So if the hypotenuse is 4, therefore this small side is going to be 2. And therefore this medium leg is going to be, well, let's find out. A squared plus b squared equals c squared. So 2 squared plus b squared equals 4 squared. So that's 4 plus b squared equals 16. Shabam, subtract the 4. We'll have b squared equals 12. And again, so now b is the square root of 12, but we can simplify this just like we did earlier, because 12 is 4 times 3. Split up the radical, and that'll give us 2 rad 3. So that gives us 2 rad 3, and then down here in the corner, our small side was 2. Our longer leg, but medium side, is 2 rad 3, and the hypotenuse is 4. Shabam. Let's try it once more. And this time I'm going to do 6. Yeah, I am. Okay, so here we go. This is 6. Half of that is 3. Shabam. Don't know what that is yet. So here we go. A squared plus b squared equals c squared. 3 squared plus b squared equals 6 squared. So that's going to be 9 plus b squared equals 36. Terrific. Now we're going to subtract from both sides, and we'll get b squared equals 27. So b is now the square root of 27, and that's going to become 9 times 3. Break it up, and that gives us 3 rad 3. Alright, let's explore and see if we can figure out what the pattern is this time. Obviously, it's not the same thing. So we've got our short side, whoop, our medium side, whoop, and our long side, aka our hypotenuse. So I'm going to put an H for hypotenuse. So let's see. Note the first one that the pattern that we started with right away was that the small and the hypotenuse were just 1 and 2, 2 and 4, 3 and 6. That's always the case. Then our medium side, aka that longer leg, all that is just like what we did earlier with the 1 and then 1 rad 3, 2, 2 rad 3, 3, 3 rad 3. We're going to take that small leg and multiply it times rad 3. Therefore, if we were to generalize this like we did with our A rad 2 for 45, 45, 90 triangles, if we were to call our long side 2A, that means that our short side would be A, and this one would be A rad 3 every single time. So again, the short side is A, the longer leg or the medium side is A rad 3, and then our longest side, the hypotenuse, is 2A.
All right, back to Goku. Open up that tab, let this tab go into the background, and keep playing. So here we go. The number 1, so now we're going on to the 30, 60, 90 guided practice, of course. So for number 1, looks like we are given the short leg here, 45. So the first one I'm going to look at is that X right there. That X, that's the hypotenuse. That means it's going to be double the 45. So 45 times 2 is 90. We would put a 90 there for that X. That's it. Then for the Y, this is where we multiply times the rad 3. But we're multiplying our small side times rad 3. Not 90, but 45. So that's going to be 45 rad 3. So again, going from small to large, this would now be 45, 45 rad 3, and 90. Now number 2, this time we are given the hypotenuse. The hypotenuse is 44, so I'm going to jump to the small side from there because we know the small side is half of that. So that'll be 44. Half of 44 is 22. So Y is going to be 22, and then X, we take that 22 and multiply it times rad 3, and you're good to go. So that'll become 22, 22 rad 3, and 44. That's it. Number 3, now this time we're given that medium side, aka the long leg. So let's see, we have 29 rad 3. Let's first figure out what that V side would be at the bottom, that short side. So 29 rad 3, well, to figure out the short side, all we need to do is get rid of that rad 3. Instead of multiplying it times rad 3, let's divide by it. Let's make it disappear. I'm literally in my head like putting a thumb over that rad 3, and the 29 rad 3 just becomes 29. That's it. Nothing else to it. So V is going to be 29. So then I think to myself, what is that U side going to be? Of course, it's double. So we take that 29 and double it. Well, let's see. 30 double is 60, so take away 2, 58. There we go. So U is going to be 58. So that one, V would be 29. The side we were given was 29 rad 3, and U would be 58. Looking at 4, 5, and 6, well, let's take a look. Again, with 4, we're given the short side. So if 5 is our short side, that means X is going to be double that, which is 10. And Y is 5 rad 3. That's it. 5 rad 3 is Y, and X is 10. Then looking at number 5. This time we're given 23 as our hypotenuse. Oh man, they're trying to trick us up by giving us an odd number. No worries, it's the exact same sort of thing. So let's see, 23 is our hypotenuse, so V is going to be half of that. Well, let's see, half of 24 would be 12, and half of 22 would be 11, so it'll be between there, 11.5. Or if you just wanted to write it as 23 over 2, that would be fine as well. Or 11.5. Literally all three of those things are the same thing. So V would be 11.5. I'm a big decimals guy. And then U would be 11.5 rad 3. That's it. Or that would be 23 rad 3 over 2. Or, you know what, don't do the mixed number thing. That is so elementary school, not in middle school and high school. So let's leave it as 23 rad 3 over 2 or 11.5 rad 3. Finally, for number 6, they gave us another kind of big one. So 32 rad 3 is the longer leg or the medium side of the whole thing. So 32 rad 3, get rid of the rad 3. Y is going to be 32, and the hypotenuse is going to be double that, which is 64. Great. So now go to the next slide, which is the independent practice. Try this one without me. I'll wait here. And so we are at the mixed independent practice. So for this, I have thrown all the 45, 45, 90 triangles and all of the 30, 60 triangles together. And wait. It's the same length. Sorry, I'm losing it. I have thrown all the 45, 45, 90, and 30, 60, 90 triangles together and mixed everything around so that you need to remember what the two different patterns are. Remember, for a 45, 45, 90, it is A, rad 2. And for 30, 60, 90, it is A rad 3, and 2A. Remember, the difference between these two is the 45, 45, 90 has the rad side as the hypotenuse, whereas the 30, 60, 90 has the rad side for one of the legs, in fact, the longer one. So when I was your age first learning that, I would get those confused all the time and think that it was just always the hypotenuse. No, it is not always the hypotenuse. So tomorrow, when we come back to this again, I'm going to throw a curveball your way, and what happens when things don't quite go as planned, don't worry. I'll be with you. We'll see it through. And but in the meantime, go ahead and give these a shot. At the end of the slideshow, you will see an answer key. But try not to look at that until the very end. And if you really, really struggle with this, please go ahead and write on the Google Classroom any of your questions. I will see them, or another classmate may see them and answer them as well. We are all in this together. So thank you so much. I hope you found this informative and educational and infotainment. And I will see you tomorrow. Have a good one, everyone.